Welcome to the video on the history of the atom. In terms of the history of the atom, it all began with Democritus in 460 to 370 BC. Democritus was a Greek philosopher that thought the world was made of four basic elements: earth, air, fire, and water. He proposed that all matter, including space and time, was made up of small units named atoms. He did no experiments and had little evidence, but his idea was on the right track. Next came Dalton. Dalton's atomic theory in 1808 agreed that all matter was created by atoms, which he believed were indestructible. He also stated that compounds were created by combining two atoms, and that all atoms of any given element were identical in their mass and properties. Next came Thompson's atomic theory. In 1897, J.J. Thomson discovered the electron. His ideas brought about the plum pudding model. This is that there is a spherical cloud of positive charge with electrons dispersed throughout. And so this is the first time that we talked about having electrons. So this was a big step in the right direction. And next we have Rutherford. And it turns out Rutherford was actually a student of Thompson's. And the quote here at the bottom: "I have never had a student with more enthusiasm or ability for original research as Mr. Rutherford." So Rutherford continued the study of the atom. He did what is called the gold foil experiment that showed that an atom is mostly made up of empty space, with electrons orbiting in a fixed orbital around a positively charged nucleus in very predictable paths. And that was in 1911. And so you can see that these scientists together created what our understanding is today of the atomic structure. Democritus, Dalton, Thomson, and Rutherford all worked independently, but ultimately their ideas came together so that we see that what we have is a very positively charged nucleus in the center with electrons in orbitals around the outside, that the atom itself is primarily made up of space with a very small, dense nucleus. And lastly, we have the Bohr model. And the Bohr model explained that the outer orbits of an atom could hold more electrons than the inner orbits. By knowing this, one can determine the atom's chemical properties. He also gave birth to the idea that electrons emit light when they're jumping orbitals. And he also showed that electrons do not exist between orbits. So it's this discrete n equals 1, n equals 2, n equals 3. So if we pull all of those ideas together, we come up with the theory of the atom today. And this is the nuclear model. There are three subatomic particles: protons, neutrons, and electrons. The protons and the neutrons are located in the nucleus, and that's a very dense central core of the atom. And then the electrons are found orbiting around the outside in very discrete levels of energy. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. And so if we focus on the table at the bottom of the slide here, we can see that the mass of a proton and the mass of a neutron is the same, and we call that one atomic mass unit. And if we look at the mass of the electron, we see that is 1/2000th of one atomic mass unit. So the mass of an electron is much, much smaller, 1/2000th of a proton and or a neutron. And so that's why we say the mass is primarily in the nucleus, and that the volume is primarily made up of those electron shells where there's not a lot of density there. A proton is positively charged, a neutron is neutral, and an electron is negatively charged. And the protons and the neutrons are both located in the nucleus, and the electrons are located outside of the nucleus. That is how we think about atoms today. There you have it, the history of the atom. Of course, there'll be more about this atom in the next video.